Well, what's up, guys? Let's take a look at another CodeWars exercise. This one's called highest scoring word. Given a string of words, you need to find the highest scoring word. And this is kind of like Scrabble, where each letter has a value, but instead of being based on rarity, it's based on order. A's 1, B's 2, and so on, all the way to Z, which would be, I guess, 26. So for example, A bad, if that were to qualify as a word, would be 1 for the A, 2 for the B, 1 for the A, 4 for the D, and that's 8 total. And we're returning the highest word, not the score, just the word. And everything's guaranteed to be nice and easy. We don't have to worry about case. We don't have to worry about bad characters or empty characters or anything like that. So the reason why I thought this was a nice problem was, first of all, it's separated into clear steps. We have to get the value of each letter, get the value of each word, and pick the highest scoring word. Those are very separate, clear, obvious steps. And the fact of what those steps are and how they connect to each other fits into some nice patterns that I wanted to mention. But let's just write them out separately for a moment. I'm going to say the letter is, well, how are we going to find the rank of these? We could just write out a list and find the index, first, second, third, or do that with a string. We could make a dictionary and have A key point to value 1, B key point to value 2, etc. But there's actually another thing that's going to end up being easier, which is a function called ORD. There's a function called ORD which gives us the, well, let me show you. It gives us the ASCII or the Unicode value of a character. So if I say ORD of capital A, that's 65. That's the one I always remember. Lowercase a is 97, I think. Let's test that out. And yeah, that's 97. So B would be 98, C would be 99, and so on. The old format was called ASCII, and it was 1 byte. Everything would go up to 128, I think, even though it wasn't really needing the whole byte. I think it was 7 bits. And once we added more characters like Greek letters, Japanese stuff, emojis, whatever, they couldn't fit in a byte. So Unicode has some things are 1 byte, some are 2 or 3 or 4, and the ones we're going to work with today are going to be numbers under 128. So let's take the ORD of a letter minus 96. So that if you minus 96, then A would be 1, B would be 2, and so on. If you didn't know about that function or you weren't comfortable with it, you could use one of the other approaches I mentioned. But let's use that, and I'm going to call that letter. I'm going to make a lambda function because these are nice and tiny, but also because I might put it in the middle of another line later. So I'm going to say ORD of L, that'll just be our letter. And just as a test, we can print letter of, let's say, C, and that should be 3, right? Great, we got it. Now we're going to score the whole word, and the word is a couple letters collected. This is a sum. That's how I'm going to do it, because I've been using sum a lot recently in these CodeWars, and it's fresh in my mind. But there's certainly other ways you could do it. Let's take the sum of letter for letter in word. So if we have 5 letters, we do each one, add them up, done. Let's test that out. Let's say their example, A bad, should be 8. And it is. We're on the right track. Now, this kind of thing in many languages is called map reduce. Okay, map is where you take some value and transform it into another one, like the letter becoming a number, and it's a 1-to-1, so each one input becomes one output. And then the reduce is where you take all those and boil it down to 1, and that's what the sum is doing here. We've got a bunch of values for the word, and now they end up as one thing. C++ calls it transform reduce. Python, we do have map and reduce in Python, but I'm using other functions to get there. And the idea is very powerful, because if you see this out there in the world in a lot of other situations, you start to automatically get into the groove and know how to write the code on your first attempt. And then we have one more step, which is picking the highest word based on its score. So we're going to use the max function from Python, which normally would get, like the biggest word or the latest word in its alphabetical order, but you can give it a key to tell it how to rank these, just like you can with sorting. Now, unfortunately, they gave it a really silly name, X, but what X is a sentence. So we have to split it into words before we score each one. So the thing we're working with is x.split, and the key is the word function that we just made. So if we get the max word based on this function, well, there we go. We got it. Now, this can be expressed in a single line. It shouldn't be a huge problem. I'm going to combine them now, and that's why I used lambdas instead of classic def style functions, because I knew I was going to rearrange them. So this guy can just be put in there. We don't even need the lambda at all, because we're going to take the sum of this little expression for each letter. Let's run that to make sure I didn't mess it up. Great. And now I'm going to use this as the key. Instead of giving it a name, I'm just going to put it directly in there. And that's what lambdas are for. If you're going to have a little baby function that you use right now and it's done, a lambda might be the right approach. And if I hit test, it's still good. Now, let's take a look at the solutions from other people and see what approaches they used. The top one is exactly the same as what we did. They took the split and made a lambda based on the sum of the ord. I wonder if you could take off the minus 96, because you wouldn't really be getting the score, but they'd still be relative to each other, like the highest would still be the highest, I think. And this one is really doing the same thing. It's just rearranged in a longer, more old-fashioned way. You make an empty list and you build up the list one at a time instead of expressing it all in one. This one is kind of doing the max the long way, because here's the thing, these algorithms are not unique. Like, it's extremely common to take a bunch of stuff and add it up, right? And we call that sum. But if you were to go through a loop, start at 0, add one at a time, you would be doing that by hand. You'd be doing it on your own. And that's great once. You should probably do that once to practice, just so you know what's going on. But then later you can say, oh, this is a sum, I'm going to call it sum. And the same thing for the max. If you ever find yourself doing this, which is going through a sequence, if this next one is better, higher, whatever we're looking for, it's the new winner, and then we go all the way to the end and see who survives. That's the max, and the way to write that is just if and a greater than, blah, blah, blah. And we've done that, just like we've done the sum a couple times in our lessons, but you shouldn't have to write that every time. You should recognize what's doing and say, oh, this is a sum, this is a max. I'm just going to call that algorithm and know what's happening under the hood. This guy is doing it the long way in both respects. He's doing the sum and the max on his own, which means you're checking every letter in every word every time compared to every other, and it makes it seem pretty tedious, even though it's doing exactly the same thing, right? It's just the fact that sum and max are so powerful that they take care of all these details for us. And this is very important to look for, not just because there's less typing. Now, it is nice to have less typing, but because when you are lost in the details, you can't step to a high level in your mind. If you step to a high level and you say, this is a max, it's kind of like freeing all that from your memory, not the computer memory, but your brain. You say, I don't have to worry about that. I say max and I know what that means. Now I can design one level higher. This is, oh, we're back to a nice one. This person used slightly different methods, OR of A, so they didn't have to remember what 96 was, because if I look at this code next week and I look at mine and I think, what the heck is 96? I might not remember. But if I look at this and I see OR of A, I go, oh, okay, fair enough. That's because you're adjusting it to the beginning of the alphabet. Great. So that one might be better. It might be a tiny bit slower if you have to run the OR function a bunch of times, but that's not what we're worried about here. Let's look at a couple more, because this one caught my eye as a dictionary. I mentioned early on that we could use a dictionary, and the only problem is it's just kind of tedious to type it out. There was somebody else, if I scroll down a little bit, I looked at this earlier, there was somebody else who just built the dictionary programmatically instead of by hand. So you just say, hey, take the letter and its index, and we get the ASCII lowercase imported instead of typing A through Z ourselves, and then we enumerate starting at 1 so we don't have to shift them over with the 0 index, and there's no +1 anywhere. He even specified you don't have to say start equals, you can just put 1, but again, that's one of those things where you look at the code and you go, wait, what is that? I don't know what that means. The start makes it a lot more obvious. And that's pretty much it. If we scroll through, we'll see some slight variations, but basically the idea is everybody's doing a sum. It just depends on whether they label it or not. If they go through one at a time and add up the numbers, they're doing a sum. If they say sum, they're doing a sum. And everybody's doing a max. It just depends on whether they're labeling it or not. If you do this kind of thing, you're hand rolling your own max, and if you call the max function, you're taking advantage of an algorithm that's already there. And the reason this is nice is because when you see other problems in the future, having a word for it makes you have a thought for it. So you go, oh, this is a sum, this is a max. If you're doing it in JavaScript or Haskell, you might say this is a reduce. If you're doing it in C++, you might say this is a transform reduce. And knowing those things helps you just jump past all the details and get to the good stuff. That's where we want to be.